All right. Hello, everyone. This is my second ever conference, so I'm really happy to give a talk here again this year. So today, I'm going to talk about making your own tool using SwiftSyntax. So how many people have ever heard about SwiftSyntax so far? OK, that's quite a lot. Nice. What about SourceKit? OK, I think SourceKit is more famous, and I don't think you love SourceKit because when you have crash on Xcode, every time SourceKit is crash or whatever. So that's like similar, like siblings to SwiftSyntax. So I'm going to talk about static analysis tool today using SwiftSyntax. My name is Yusuke. All right, and my social account name is Kitasuke. And I work for Mercari as software engineer. And I am a tiny contributor of Swift compiler, SwiftSyntax, and also Swift format. So we develop apps. It could be iOS, it could be macOS, it could be watchOS, tvOS, any OS on Apple platform. And I think there are mainly two things we often touch. First one is, of course, source code, which is most important thing, and also tools. There are so many tools we use, like SwiftLint, FastLane, or even Xcode. I think we can consider that as a tool. And I don't think we can do anything without them. So I believe tools are also important, because tools help make programming easier. These tools significantly make your source code better. So before we dive into SwiftSyntax, I like to introduce some tools using SwiftSyntax so that you can imagine what we can do with SwiftSyntax. First, SwiftUI previews. You know SwiftUI, right? That's like bright new features from Xcode 11. And Xcode 11 also provides preview feature for SwiftUI. All right, so this is how it looks like. So left side, it's source code. And right side is preview feature for SwiftUI. And one thing I really like about SwiftUI is it is a single source of truth. So no storyboard or nibs anymore. If we modify some components on previews, that's reflected in source code. And same thing happens in the other way around. And in this part, source code is generated by SwiftSyntax. Next, Swift format. I don't think many of you have heard about Swift format yet because it's still under discussions. But this Swift format will be an official formatter tool for Swift language. If you're curious about the detailed discussions, please go to this link later. And for now, you can think of Swift format as SwiftLint. So this is a lint/format tool for Swift language. Next, SwiftConst. It is an inspector tool to finding repeating strings in your project developed might be. But please be aware that this is still beta versions. So I probably extend this tool to finding other repeating things like functions or maybe protocols or such kind of declarations. This is an example of output on terminal. So if you run this command, you can see raw strings. Like in this case, error and help are used for multiple places, multiple times. So I think this is better to have them as constants instead of having raw strings in many places. So that's what SwiftConst does. Okay, so I believe that you already saw the power of SwiftSyntax. It's very powerful, and I think it's a great tool for Swift tools. So what's for? I think there will be many more tools using SwiftSyntax, but there are mainly two things you can do with it. One is code modifier, / code formatter, code generator, whatever tools you can that can generate Swift source code. Because SwiftSyntax allows you to change or even generate new Swift source code. And another thing is code analyzer / code inspector, code linter. So SwiftSyntax allows to inspect Swift source code. So SwiftSyntax is developed for these objectives. So that's why this is very powerful, and there are so many things you can do with it. So we already covered what SwiftSyntax is for. So let's move on what it is. SwiftSyntax is a set of Swift bindings for the libsyntax library. And it allows for Swift tools to parse, inspect, generate, and transform your Swift source code. So it's just Swift bindings for the libsyntax. And next question would be, what's libsyntax? I don't think that's very famous tool for Swift developers. And libsyntax library aims to represent the syntax tree of the source file. So libsyntax creates like whole syntax tree of your source file. I guess you already know like what kind of what syntax tree looks like, but I prepared just one example here. So here's an example of syntax tree for 1 + 2 in Swift file. Actual syntax tree has more context, so it might be a bit longer, but just an example here. So expression list has 3 expressions here. Integer literal expression, which is like literally int value, and binary operator expressions, which is here plus operator, and then again integer literal expression again for 2. So we can express our Swift source code with this syntax tree by using SwiftSyntax. Okay, so simplified version of SwiftSyntax is it parses Swift source code to syntax tree. That's it. That's really simple, right? Okay, so next, let's move on to like how to emit syntax tree. Well, this, I don't think we have to do this every time, but it would be nice to have, what kind of syntax you have, or what kind of syntax you could have for different type of Swift source code in the future. So actually, there is one option, which is emit syntax. So this process inputs Swift file and then emits syntax tree as JSON file. And this is an output for same example 1 + 2 as Swift input. Well, again, actual output is much longer than this, but this is just example. So, but still, I think you can see the structure of source file. Again, from the top, it has source file expression and code block items, expressions, and detailed expressions. If you're curious about other syntax as well, feel free to give it a try with your different input later. However, sometimes JSON output is too long to read, so I like to share a great tool to show syntax tree in a better way. This tool is called SwiftAST Explorer, developed by Katsumi. And this gives you HTML output instead of JSON, so that you can easily check it on your browser. So left side, this is Swift source code. And right side is syntax tree of Swift source code. And then if you move your cursor on each syntax, you can see detailed information there. So you don't need to look at everything at one time, but you can just focus on specific syntax you need on your browser. This is really simple. So that's why I mentioned that you don't need to run emit syntax on your terminal every time, but instead of that, you just go to this browser and then see how it looks like. Okay, so let's recap. SwiftSyntax is a parsing tool for Swift, and it emits syntax tree, and it allows to inspect and transform source code. Source code is like a giant string value. So we cannot distinguish whether it has functions or let var declarations or if it's protocol, because it's just a huge giant string. So that's why we need syntactic information in the source code. So that's why we need SwiftSyntax when we develop those kind of tools. Okay? All right, so let's move on how it works. SwiftSyntax is available via SwiftPM. So in your package file, you can just specify SwiftSyntax as one of the dependency here. And I strongly recommend to use release.dat because master branch doesn't have any auto-generated file from Swift compiler. I will briefly show you some interfaces for integer literal expression case here. First, syntax parser. You need to parse Swift file to syntax tree first. And syntax parser literally is an interface for that. There is one parse function in syntax parser, so just call this function with URL of your source file so that you could get syntax information, which is called source file syntax here. So that's a huge, that's a top level syntax node of whole Swift source. And optionally, you can also pass diagnostic engine, but I don't think that's needed here. So remember, just pass URL of your source file, and then you get source file syntax. All right, next, source file syntax. That represents structure of source file. And it is a top level syntax node in your source file. So again, same example, but you can see source file syntax at the top. And from the top to bottom, it's same example of a source file syntax has children, and then those children has another children. So this is a structure of source file. And you can see along with syntax like integer literal, you can see trivia, which represents how many spaces you have, how many new lines, comments, those kind of not really important information, but it's also semantic information with the syntax itself. So with this, we can analyze very deeply. Like for Swift, if you want to make a linter tool, you can focus on these trivia because it has spaces, like lines, comments, and so on. All right, next, syntax. There are so many syntaxes defined in SwiftSyntax, but let's dig into integer literal expression case for now. So integer literal expression syntax, it is a struct, and it has a digits property here of token syntax type. token syntax is a syntax node representing a single token. So syntax and token, it's a bit different thing. If you're familiar with like Lexer, so all the source code will be converted to tokens first. Like it's a minimum chunk of information of text, like that, func, like identifier, protocol, those kind of things. And syntax, I think it's a bit, it's a more well-organized structure. So each syntax has each smaller token. So it's kind of, a parent-child relationships. But for now, you can think token as a syntax. So you can think of like two things as the same thing. Anyway, so important thing here is that it has text property, which is string. So whenever you wanna access to raw value, like in this case, I'm showing you an example of integer retail expression, and that must have integer value, right? So to access that, you can see text property to get that. However, you cannot get it as int value. It has to be, everything has to be string. So if you have like 1 as integer retail expressions, you can get 1 as string. Okay, so there are more syntaxes as well, like identifier expression syntax, array expression syntax, dictionary expression syntax, function call expression syntax, blah, blah, blah. So this is just an example. There will be more syntaxes, but you don't need to deal with all of them. Like it depends on what kind of tool you want to make. If it's linked to, yeah, you have to deal with all of them. But if you want to make a tool specific for like integer value or maybe functions or protocol, the only thing you have to deal with is that you like related syntaxes. Okay, so syntax visitor, that provides a way to visit each syntax. Here is visitor functions for integer retail expression syntax. One above is for visiting. So this function visits syntax tree from the top to bottom. So these functions can return whether it should continue to visit children or skip them. So every time this visit functions visits from the top to bottom. Okay, and below one is for after visiting. So these are places where you can inspect or analyze like really detailed things for specific syntax. These visitor functions are defined for each syntax. So this is only for integer retail, but we have another visitor functions for other syntaxes as well. Okay, so next syntax rewriter. This provides a way to rewrite each syntax. This is another visitor function for integer retail expression syntax. In here, you can return whatever syntax you want as integer retail expression. It can be existing one, or like a little bit modified one, or even a totally new one. So that's how we rewrite our Swift source code. Okay.
Sorry. Is that okay?
Yeah.
Okay.
It's all good?
Apology, everyone.
It's all good? All right. Where are we? Oh, yeah. So this is a place where you can transform the existing syntax to new one. Okay, I think this is final one. Syntax factory. This literally provides the convenience factory methods to make its syntax. So this is a factory method for integer literal expression syntax. It takes digits as an argument and return integer literal expressions. Well, you don't need to remember everything because, you know, these convenience functions does this complicated syntax creation for you. So like there is no reason not to use this function method other than, you know, you creating your own syntax by yourself. So as long as you use this factory method pattern in SwiftSyntax, you don't need to deal with like raw syntax or syntax data, which is different data types. All right, I think that's enough lectures. So I want to showcase two actual use cases for the Swift tools during my talk. First one is odd number inspector. So both of my tools is not really useful in actual projects. So this is just example. So this tool is a super lightweight linter. This tool tells you to use even number instead of odd number for UI code because, you know, sometimes designer is yelling at, hey, you know, this is odd number, right? Well, this example is like height for table view cell, and then we like unconsciously use 44 for table view cell. But you know, sometimes we made a mistake, right? And it's gonna be like 43, 41. But this tool tells you that hey, you should use 44 or 42 instead. So it's really simple linter. For this case, syntax visitor works for this tool. And visit post function allows to visit integer literal expression syntax because we just want to take care of integer, right? So that's why we use visit post functions for integer literal expression syntax only. And then you can get integer literal expression syntax node here. So if you take node.digits.text, you can get raw value of Swift source code. And as I tell you, that's string, even though you know it's integer literal value. So we have to cast it to int first. And then if it's even, we do nothing. And then if it's odd, we just print warning. That's it. It's really simple. And finally, since this is going to be command line tool, you have main.swift file. And we have to pass Swift source code to syntax tree first, which is source file syntax. And then we have to walk them with the visitor we defined. But basically, that's it. So if you run this command, well, this doesn't print on the actual line. This warning should be on terminal. But you know, that's almost everything what you have to implement for your tool. With this, you can make your own linter for Swift tools. So my next example would be code formatter. This is also a useless formatter, but it just multiply by 10, or it just multiply integer value by 10. And it doesn't mean anything, really, but just an example. So like I said, this tool formats int value to multiply by 10. To do so, we need to rewrite integer literal expression syntax again. So this case, syntax rewriter works for you. And visit function allows to rewrite integer literal expression syntax. like I said, let's use syntax factory to make a new syntax node for integer detail. Like I said, you can access to raw value by looking at node.digits.text so that you can get actual value as string, and then you have to cast it to int. After that, when we make a new syntax node, we have to multiply that by 10, which is this line, right? So that you can get new syntax node, which is digits here. And finally, create a new integer literal expression syntax with the digits so that these two can format your Swift code. This is it. Again, you have to parse Swift file to get Swift source file syntax, and you have to work them with the visitor we defined in the same way. If you run these two on your terminal, it's already formatted to this code. So you don't need to do like other things besides that. This is all about formatter. Okay, so these are just like useless examples, but I think you can make more practical tools for your project. Sometimes it can be more general, like SwiftLint, but sometimes it's just for your internal tools for your specific projects. But I think that's okay, because any tools, I think whatever tools can help you a lot to make it more productive. And these tools definitely make your code much better. And you have to admit that sometimes, tools are better coder than you. For some cases, or maybe most of cases, I don't know. It depends on your project. But definitely if it's really simple and then routine kind of things, I would say, like letting tools to work for you is a good option. So that's why we want to have this kind of tools. Like a good example is SwiftLint, right? We don't want to fix, like spacing, how many lines every time. So that's why we need these tools. So don't overestimate you. Let them work for you instead. So honestly, comparison with SourceKit is not my scope during this talk. But before ending my talk, I'd like to mention about some big improvements in SwifSyntax, because at least last year, many people said, "Hey, like SwifSyntax is too slow." SourceKit is much faster than SwifSyntax last year, definitely. But they're having great time to improve like all the things, and first one and second one will significantly speed up Swift compiler itself. These are too much detail, so I'm not sure if it's worth like reading all the documents here. But if you're curious about that, I think it's worth checking out. And last one is pretty interesting because one of contributor is going to use function builders for syntax creations. So I mentioned about syntax factory, right? That's static functions. So we have to call static functions again and again and again. But what if we can express that by using function builders? It's going to be more declarative and then easy to understand. So that's something I think more expressive way for SwiftSyntax. So these kind of improvements actually happening right now. So oftentimes comparison with SourceKit is a not really good discussion for SwiftSyntax itself, but things are changing a lot. So if SwiftSyntax is still slow for you, but it will be changed 1 year in 1 year later. All right. So Swift is statically typed language, right? So that's why we can have like these kind of tools, static analysis too. So you should take benefit of these language features. I'm not sure about Objective-C. Maybe we can have these kind of tools. Maybe, but I don't think it can be more like expressive like SwiftSyntax. And I believe these useful tools make better apps. So as long as you have ideas, I think it's worth having a tool. Or it can be script, but you know that I think that levels up your source code quality of source code and also the quality of app itself. And like I said, SwiftSyntax is improving so much, and it's changing a lot. I don't think that's not. I think that's still beta version yet. I'm sorry, I'm not sure about this version yet, but yeah, I don't think it's. Yeah, I think it's still beta version. So it is changing a lot. So if you're interested about using SwiftSyntax, I think you should watch like their moves a lot. All right. So as reference, I had a link for SwiftSyntax, and this is not really recommended, to be honest. But if you're curious about libsyntax itself, I gave a talk about like how libsyntax works in Swift to C meetup, not Swift meetup, which is because this talk might be boring for Swift meetup. So there is like monthly Swift compiler meetup in Japan. So that's a place I gave this talk. But this is about like how they integrate libsyntax to Swift compiler pipeline, so that they can speed up SwiftSyntax. All right, that's it from me. So thank you very much. If you have any like ideas or questions, just ask me. Thank you so much.